Audio Jungle. Audio Jungle.
Hello everyone, myself Naren Singh Maurya. So guys, we'll start here that compressible flow topic. So now, if I say compressible flow, right? So before going into this deep analysis of the compressible flow, we'll have a basic analysis first. So I must say state of matter. The state of matter. So basically, if you talk about the state of matter or substance, so in mechanics, state of matter is one of the distinct form in which matter can exist. Basically, we have four states of matter. How many? Four states of matter. What is that? It's nothing but solid, liquid, gas, and plasma. Okay. So here we'll talk about the these three parts because that plasma is what nor not our topics of study. Okay, so we'll have a solid, liquid, and gas. All right. So solid, liquid, and gas is called as a fluid. In short, I'm telling you. Okay. In solid is the one basically you can say, and this two are combined, which is called fluid. So for that reason, based on this solid and fluid, we have the study that is the deals with the behavior of state of matter. Okay, that is called mechanics. Okay, deals the behavior of the state of matter. It doesn't matter it is at rest condition or it is at motion condition. Based on that, another classifications are there. But mechanics means what? That behavior of state of matters we have to deal. Okay, so now, so these are classified. I will make one tree so it will be more clear to you. Okay, it is nothing but this is the just introduction. Okay, state of matter. Okay, it may be solid or fluid. No? All right, and this will be the study of this state of matter called mechanics. Okay, called mechanics. Now this combined will be divided in basically two parts called solid mechanics and fluid mechanics. All right. Again, as I mentioned, mechanics is what? It's a dealing the behavior of a state of matter at rest or motion condition. So, because we are going to talk about the compressible flow, so means we are going to talk about the flow. That substance is what? Flowing condition. So definitely our focus, because fluid is the flowing substance, so our focus will be on fluid mechanics, not solid mechanics. So here in compressible flow we'll not talk about this mechanics, we'll talk about this mechanics called fluid mechanics. And this fluid mechanics, again, it is divided, okay, called fluid static, and here this is fluid dynamics. Fluid dynamics, all right. Again, because we are talking about the compressible flow, we are going to talk about compressible flow, about compressible flow. So that means fluid is what? In flowing condition, means in dynamic conditions we will not talk about the fluid static, because if you go for the fluid static, so I will write examples so directly we'll understand that fluid static means what. Example, I will tell you what is the mean of fluid static. That is called uh, like hydrostatic law comes under fluid static. Hydrostatic law, hydrostatic law, when flow is what? In static condition, okay. Pascal law, Pascal, Pascal's law, okay. So this type of law came to a fluid static condition. If you talk about fluid dynamics, so that, because I told you compressible flow means you are going to talk about flow, not static condition. It should be in motion condition. So that is, this is not our concern basically. What is our concern? Our concern is this fluid dynamics again. So again, this fluid dynamic is what? Divided in two parts, okay. This is called hydrodynamics. Hydro means what? Water, because fluid means liquid and gas both. So liquid means like example of liquid is what? You say water. So that's the reason it is given hydro. Hydro means water. So hydrodynamic, if you talk about the, you know, pipe flow in fluid mechanics, we have seen pipe flow and Bernoulli equation, sprinklers, all those things that comes under hydrodynamic, okay. And obviously hydro, that is water, and water is what? Incompressible. Again, I will classify what is the mean of compressible and incompressible, but I must say, like, incompressible means which is not ready to compress, like water. Water easily cannot be compressed. If you are applying thousands of kPa pressure, then it maybe density will change little bit, so you can say okay, now it is compressed little bit. But generally, how that, for a small pressure variation, water density will not be changed, it means it is incompressible. It is means density is constant. So that hydrodynamics and all, like Bernoulli principles and pipe flow and all, it comes under incompressible flow condition. Incompressible, incompressible. All right, that example of. Hmm? Now coming to this, as I told you, this fluid considering liquid and gas both. So liquid parts come under in dynamic condition. Liquid parts comes under hydrodynamic, and gaseous part comes under gas dynamics condition. Gas are very easily compressed with even a small pressure variation. Hence, you can say it is compressible. Okay, so that gas dynamics. will be called compressible flow. Okay. So again, I told you like our analysis is not incompressible flow because our heading is what compressible flow. So that's the reason again we'll not talk about this because we already have done this. I think in third semester mechanics of fluid. We'll talk about the gas dynamics. This is our main concern in this session. The whole session will be covered this gas dynamics parts. Okay. In under this gas dynamics, we have to talk about the compressible flow and how to analyze this compressible flow. We have you know one non-dimensional number called Mach number. All right, called Mach number. Similarly, like incompressible flow, like hydrodynamics, okay, pipe flow and all. You may have seen in mechanics of fluid that non-dimensional Mach number was Reynolds number. Okay, so here we'll talk. I mean, if you want to express this incompressible flow, that analysis, if you want to do, then uh, Reynolds number you will use, and here what number you will use? Mach number M. Capital M is the Mach number. We'll talk about this Mach number and Reynolds number analysis you have seen already in mechanics of fluid in hydrodynamics. So this is the exact what I wanted to explain, like that how to reach to the compressible flow, because that our point is my point is what, like what is the analysis of the compressible flow. I mean, how you will reach to compressible flow. So you will start from the state of matter, from very basic. Okay, and then this is the whatever the talk here I have done, that is related to compressible flow. So compressible flow you can get at this point. All right. Now, so I hope up to here it is clear. Okay. Now we'll go for the very basic definition of the compressible flow. So what is the compressible flow? Compressible flow. So compressible flow, it is defined variable density flow. Simple. Compressible means what? I told you, like it is ready to compress or it allows the compression. Compression means what? Simple density variation or change of density comes under the compression. Okay, if you are doing compression, it means density is what going to change for any fluid. It doesn't matter it is liquid or gas. If even I'm saying for the water also, if I'm saying it is you are talking about compressible flow for the water, it means water density is what going to change, like water hammering and all. You might have heard this word, water hammering, in case of the even high flow also, water hammering. So that water hammering is what, that is the one the output of the, like for the compressible flow. Okay, mean, because their density was changing in water hammering, what happening basically, that density was changing. So density is what changing, it means it is compressible flow. So I must say it is defined, a variable density flow. Means what? Means density of fluid changing point to point. Density of fluid, okay, density of fluid is changing point to point, here. Okay, that means it is the compressible flow. Okay, that is the one point I wanted to tell you. So if density of fluid rho which is not constant, then it is called compressible flow. Okay, I must say, like, suppose this is the flow here going on. Okay, I'm saying 2 points. This point density is what rho 1, and at another point this point is what density rho 2, and both density are not same, then it is called compressible flow. Okay, it means it is a compressible flow. Why? Because density is what? Not same. If throughout the flow density is constant, then it is called incompressible flow. So that's the reason where it is happening in liquid or gases. Yes, it is happening in case of the gases. Okay, because liquid like water, kerosene. Okay, so in that case density is what? Almost constant. Even if we are changing the pressure also, density is what? Not going to change significantly in case of liquid. So for that reason only, liquid study of the fluid called incompressible flow when it is the liquid state. Okay, that is also one more point you need to remember, because if it is liquid state, it means density is what? Almost constant, it is not going to change. If it is not going to change, then it is called incompressible. But gases, like, it is very easy to change the density by compression. It is very easy to change the density of the gases. Hence, if you talk about compressible flow, it means it is 99.99% it is a gas. Okay, maybe air, right? Nitrogen, oxygen, whatever the types of gases are available, it is the example of compressible flow. All right, hope you understood this. It's very simple. Now I will use one word which is the useful for the compressible flow, that is the property of the fluid also. Okay, called compressibility. Compressibility. Okay, compressibility, it is denoted by capital E. So what is the compressibility? It is the property of fluid. Okay, it is it is the property of fluid. Okay, it is used to it is used to measure the degree of compression degree of compression of fluid, and it is reciprocal of bulk modulus. It is reciprocal of bulk modulus, and that bulk modulus is what denoted by capital B, or it is denoted by capital K. That meaning is same. So what is the compressibility? Compressibility is nothing but, I will tell you what is the physical meaning of this, physical significance of the compressibility and bulk modulus. So E is nothing but reciprocal of bulk modulus, or K is equal to 1 by, that's the mean of it. Okay. Now you just connect it so you will understand easily. See, suppose this is the cylinder. Okay. In this cylinder, anyway, no problem. So here we have a piston. Okay. This is what piston. Now here gas particles are available. Okay. Now for the same cylinder, if you check the piston, the pressure available here is what P. Okay. And the volume of the cylinder is what V. Volume of the cylinder is what V. Alright. Now next time what will happen? The the same piston cylinder arrangement we have here, but properties are now going to change. Means this piston is what moving downward. This piston is what moved downward direction. Okay. So when it will move, simple. When it will move in downward direction, because inside gases are available, right? Gaseous particles are available. So obviously, if you say piston are going to move in downward direction, means you are increasing the pressure. What pressure you have increased? dp pressure. So p pressure was already there. Now you have added dp pressure. Like earlier was 1 bar, zero point 0.5 bar you have added, so it become 1.5 bar. So p plus dp. Now what are the quantities are going to change? Basically pressure becomes p plus dp, and earlier volume was v. Now because it is moved in downward direction, okay, it is moved in downward direction here, this distance traveled, and this distance you can say this is nothing but dl length or l length simply. So area of the piston is nothing but a. So what will be the volume? Volume will be area into dl, or area into length, what it is, what distance it is traveled in downward direction. Okay. So if I say, suppose dl distance traveled in downward direction, so volume changed is what? dv. So this dv volume will be decreased. You understood why? Because piston is what moving in downward direction. So what is the volume decreased? It is nothing but dv. So earlier volume was v. Now volume dv is what decreased. Why? Because piston moved in downward direction. So what is the remaining volume you have here? It is v minus dv. Hope you understood this. Simple. In very short, I am giving this derivation. Okay. P was the initial pressure, V was the initial volume of the cylinder, dP was the increment in pressure, okay, for the piston, and dB was the decrement of volume in cylinder. So now this is the scenario. So what is the mean of compressibility? Compressibility is saying like what is the degree of compression, means how much fluid is what compressed. That means compressibility. So here if you check, whatever the fluid available inside the cylinder, means gas, it is compressed, then only that piston is moved in downward, means it is ready to compress. If it is not ready to compress, then why piston will move in downward direction? Simple logic, you need to understand it. Yes or no? So here you can write P is initial pressure, dP is increment in pressure. This is for the piston. V is the initial volume, dV is decrement in volume. This is for why it is decrement in volume, because piston is occupying space while moving in downward direction. Yes or no? So what is the change in pressure? What is the change in pressure? Final minus initial. Yes or no? Initial. What is the final pressure? P plus dP. What is the initial pressure? P dP. Okay. Now, what is the change in volume? Final minus initial. What is the final volume? Check. V minus dV. Yes or no? Initial volume is V. How much? Minus dV. Yes. So, if I say what is the change in volume means what? A specific this is because this is the specific volume. If a specific volume is what changing means what? Density is what changing. I will tell you the relation. Okay. Now, so volume of the fluid is what changing, because piston is what moving downward. So obviously fluid is what going to compress. That's the reason it is going to move in downward direction. Okay. It means it is allowing the piston to move in downward direction, means it is accepting, fluid is what accepting the compression. That acceptance of the compression of fluid called compressibility. Okay. Compressibility is more, it means acceptance of fluid to compress is what more. And obviously it is compressed. Why? Because pressure you are applying. Otherwise, pressure if you are increasing and increasing, but fluid is what not allowing the compression, I mean fluid is what not going to compress. So it doesn't matter whatever the amount of pressure you are going to change, like for water, even thousand of Newton per meter square pressure if you change, then liquid water density is not going to change significantly. So finally you will say okay, it is incompressible, it is not ready to compress. But at the same time, 1000 Newton per meter square pressure if you apply to the air, then it is ready to compress easily. So you will say okay, it is accepting the compression, hence it is compressible flow, and hence it is having the compressibility. All right, hope you understood. So very slow I'm going, because this is the first session. Next session definitely I have to go fast, but this basics should be very clear. Okay, because simply reading the definition is not enough, I think. because this subject itself compressible flow. So we'll talk uh, elaborately about this topic first, then we'll start session. I mean, simple derivation we'll do later on, no problem. Anyway, if I say what is the bulk modulus, so bulk modulus is nothing but it is it is defined as the ratio of change in pressure to volumetric strain. Okay, number one. Number two, it is it is it is the resistance for compression of fluid, just like a resistance for the current. Okay, opposition for the current called resistance. Okay, same way you can call it is the opposition or against the compression. Okay, if you are going to compress but fluid is what resisting that compression, then that resistance of the compression is nothing but called bulk modulus. Hope you understood. This is the physical meaning I am telling to you, because see, bulk by first point will tell you what is the mathematical model. Second point will tell you what is the physical model of the bulk modulus. So just like a compressibility, what is the physical significance? It measures the degree of compression called compressibility. It measures the degree of compression called compressibility. Similarly, bulk modulus. The bulk modulus measures the resistance of the compression. So compressibility will allow the compression and bulk modulus will oppose the compression. Both are opposite. That's the reason it is initially it is clearly mentioned it is reciprocal to each other. So here I am talking about the physical significance of the compressibility as well as physical significance of the bulk modulus. Okay, you listen precisely, because see, as I told you, this is the very basic things I am telling to you. So first I will clear this, then I will go fast. Okay, I am taking time for this particular topic. Anyway, so what is the bulk modulus? It is opposite to compressibility, and obviously compressibility will, remark point I will write here. Compressibility will allow compression of fluid. Okay, point one, point two. Bulk modulus will oppose compression. That's the reason both are opposite to each other. Both are opposite to each other. I hope now you understood why it is opposite to each other. By physical significance, if you understood, then automatically you will understand why it is opposite to each other. Okay. All right, done. Remember this point, these are very important point, physical significance. Now bulk modulus, here as a first point I have mentioned, bulk modulus is denoted by capital B, or few books it is given by capital K. Okay. It is nothing but change, it is defined by the change of pressure, ratio of change of pressure to the volumetric strain. What is the volumetric strain? Volumetric strain. What is the strain? Strain means original length. Change in length divided by original length. Not original by change. Change in by original. Okay, sorry. Let me correct this. So it is volume. Okay. It is volume. So you will write change in volume divided by original volume. What is change in volume? dV by V. Original volume is V. Check. What is the change in volume? This is the change in volume. Hmm? Change in volume. Final minus initial. Change in volume by original volume. Here. Why this negative sign? Change in volume. I will write the value, then I will tell you. So it should be change in volume. You are getting negative, so it is dV by. So basically, K is nothing but change in pressure. Change in pressure. What is the change in pressure you got? dP. Check here. Change in pressure is nothing but dP. dP divided by volumetric strain, which is nothing but change in volume by original volume, which is nothing but minus dV by V, or you can say it is minus dP divided by dV by V. Okay. This is the bulk modulus K or B. Minus sign, minus sign indicates what it is indicating. It indicates pressure on piston increasing, hence volume decreasing. Yes or no? That happens. I have shown you. If check, you have increased the pressure, dP pressure you have increased, so dV volume was decreased. Means change was, volume was decreased. Overall volume was decreased here. So negative sign indicates pressure increases, hence volume decreases. That's the mean of it. Okay, very good. Now, if you go for the volume, okay, what is the specific volume? Specific volume means what? It is volume per unit mass. Yes or no? That is called a specific volume. So volume is what? Capital V. Mass is what? M. And specific volume will be denoted by small v. So small v is equal to 1 upon m by v. What is mass per unit volume? It is density means 1 by rho. Means what is the specific volume? It is 1 by. So even though this is the volume, okay, total volume, but if you convert this dB and V in a specific volume, so mass will cancel out. So you directly you can write minus dP divided by small v small. It becomes now a specific volume. Now check. From the same, I will write a small volume means a specific volume by rho. So rho into a specific volume is equal to 1, which is nothing but constant. Can I take a partial differentiation? So rho dV plus V d rho is equal to 0. 1 is constant, so constant differentiation is 0. What is the conclusion you got here? You can write dV by V small v is equal to what? Minus d rho by rho. Yes or no? Check. This is equation number 2. This is equation number 1. So from equation 1 and 2, equation 1 and 2, what we got? K is equal to dP. So you can write dP minus, what is dV by V got? You got here, it is minus d rho by rho. So it becomes, check, minus minus plus rho dP by d rho. Yes or no? This is the value of K, rho dP by d rho. Yes, that is the bulk modulus. What about compressibility? Compressibility is nothing but 1 by K, hence it is d rho divided by rho dP. Okay. What is the d rho here? Or what is d rho? E rho into dt. Yes. What is the mean of it? What is the mean? E is equal to 1 by K. This is what? Just opposite. Wait, here I made mistake. Let me correct this. Let me correct this. 1 by K. K is nothing but d rho will come this side and rho dp. Okay, fine. So what is the d rho? It is E rho into dp. Yes or no? Now, if you check, you can write here E is that d rho is directly proportional to dp. You can say d rho directly proportional to dp. Okay, from this point, and E is directly proportional to d rho. Two things. D rho directly proportional to dp means what? Even though change of the pressure directly comes to change of density, that's the mean of it. If I say d rho is equal to rho e into dp. So d rho means what? Directly proportional to dp, because E is the property of the fluid. Okay, compressibility, as I told you, it is property of fluid, so that will be constant. For water, it is constant, means constant, it is not going to change. If value will be changed, then that value of pressure will be changed, then density will be changed. That's the mean of it. Yes or no? So d rho directly proportional to dp means what? Even though a small change in pressure, even though small change in pressure, significant change in density of fluid will be observed. Yes or no? It comes. Okay. So if you have change in pressure in a fluid anyhow by the piston or any another mechanical way, or any through mechanics, if pressure will be changed for the fluid, so automatically density will be changed. Okay, that is called compressible flow. And that compressibility will be used to measure the degree of compression, how much it is changed, that density, how much it is changed, that will be measured with the help of compressibility. That's the mean of it. If you check by the formula here, already I have written in previous slides, E is also directly proportional to d rho. Means this compressibility will directly make proportional to change in density, means that indicates whatever the change in density, that directly will point to the compressibility, or compressibility is used to measure the change of density, used to measure the degree of compression means change in density. I hope you understood. So whatever the point I have explained today, it was totally basic and just for the you know idea purpose. You should have an idea about the compressible flow. Then only will start the topic, because directly I can start the topic, no issue. But my point was like, you should understand the basic. Okay. Compressibility. Compressibility is directly proportional to change in density of fluid. It will measure the degree of compression. Hence, it will measure the degree of compression. Hence, compressibility will measure the degree of compression. So today whatever I have explained, it was completely basic of the compressible flow, basic of the introduction of the compressible flow. All right. In next class, I will the derive this speed of sound and then Mach number, then how to relate that you know speed of sound and bulk modulus, compressibility, and then whatever the topic will continue. Okay. All right. Thank you so much. Thank you.